LeetCode problem 2139, minimum moves to reach target score. This is a recently added algorithm problem of medium difficulty. And in this problem, we are playing a game with integers. You start with the integer 1 and you want to reach the integer target. In one move, you can either increment the current integer by 1 or double the current integer. You can use the increment operation any number of times. However, you can only use the double operation at most max doubles times. Given the two integers target and max doubles, return the minimum number of moves to reach target, starting with 1. So in this problem, we want to go from 1 all the way to target. And I'm just going to run through some examples. So we're going to start at 1 and we want to get all the way to target in the most efficient way possible. And I just want to get a feel for this problem. So I'm going to use a random approach to start. So the first thing we want to do is increment. This will give us 1 move. Now let's try doubling. This is going to skip 3 and go right to 4. And let's increment again. So we're going to go from 4 to 5. That's our third move. And let's increment again and go from 5 to 6. That's 4 moves. And let's use another one of our doubles, go from 6 to 12. That cuts out 5 numbers in between. So that puts us at 1, 2, 3, 4, 5 moves. And we're now out of doubles. So we're just going to increment the rest of our way at 6, 7, 8, 9. So this gave us a good feel for the problem, but I want to take a different approach now. So what I want to do is start at our target and go backwards down to 1. So now that we are starting with a larger number, we can most efficiently use our doubles immediately. So let's go through this. We're going to start at 16 and we're going to want to cut it in half all the way down to 8. So that cuts out 7 numbers. Then we're going to want to use our double again. And this is going to take us from 8 to 4. So 3 more numbers we don't have to account for. And since we're now out of our doubles, we can just decrement the last 3 times to get to 1. So this gives us an answer of 5, which is much more efficient than the random approach we took earlier. So we, in this example, we started with an even number, which made it easy to divide by 2 and get to, in this case, another even number. So what I want to do is try another example where we start with an odd number. Now, we're starting at 17, and we can't divide that by 2 because it will give us 8.5. And once we start messing with decimals, we're not going to end up at 1. So what we're going to want to do is just decrement this by 1. And the best way to tell our algorithm to do this is to tell it if target mod 2 is equal to 0, we're going to want to use our doubles. If not, then we're just going to want to decrease by 1. So in one move we go from 17 to 16, and then we can do exactly what we did before, which is you start using our doubles and go from 16 to 8, then go from 8 to 4, then just decrease the rest of the way. So this is working, but I want to do one more example that further explains why we check for if the target is even or odd. So in this example, we have a starting target of 19. So we recognize that 19 is an odd number, so we're just going to decrease by 1. Now we have 18, which is an even number, so we're going to want to divide by 2, which brings us to 9. Now we're back at an odd number, so we want to decrease by 1 to go from 9 to 8. back at an even number, we can use our last divider and go from 8 to 4. And then, since we're out of dividers, we can just decrement the rest of the way. So now that we kind of have this diagrammed out, we can start writing the code for it. Okay, let's start writing our code. So the first thing we're going to want to do is set a variable to keep track of our moves. And we're going to call that moves and set it equal to 0. Now, as we wrote out in our diagram, we're going to want to start at the target and work our way down to 1. And we can do that using a while loop. So we're going to say while target is greater than 1. And once target is equal to 1, this loop will end. And at the end of this, we're going to want to return our moves as our answer. So now inside of this while loop, the first thing we're going to want to do is check if the target is even or odd. So if target mod 2 is equal to 0, now inside of this, we're going to want to check if we have any max doubles. So if max doubles is greater than 0, then we're going to want to set the target to half of its value. So target divide equals 2. And then max doubles, we want to decrease by 1. And we're going to attach an else to this. So else, if we don't have any max doubles, we want to decrease the target by 1. And then we're going to attach an else statement to the first if conditional. So if we have an odd number as our target, we're just going to want to decrease the target by 1. And at the end of this conditional, we want to increase our moves by 1. So this code does work. I'm going to run it with the test cases, but there is a concern. So as you can see in constraints, the target can be all the way up to 10 to the 9th power, which is a pretty big number, especially if we don't have any max doubles. So I'm going to run this test case with some pretty big numbers and 0 max doubles. And when I run it, it's going to run pretty slow because what happens is it's going to check if target is even or odd. Then it's going to check if we have any max doubles. And if we don't, it's going to decrease it by 1. And then it's going to start back into the for loop. And this is going to continue running, just decreasing by 1. And as you can see, this took 6,000 milliseconds. So it's not very efficient. And if I were to hit submit, it would actually fail with a time limit exceeded message. So this, although it works, is not efficient at all, and we can actually write it better. So the first thing I'm going to want to do is actually check for max doubles before I check if target is even or odd. And then we're going to want to keep this code. We're going to set target to half of its value. We're going to decrease max doubles by 1. And then if it's not even, we're going to want to decrease target by 1. And then at the end of this loop, we're going to want to increase our moves by 1. So now we're left with an else statement that is returning whether or not max doubles is less than or equal to 0. So instead of just decreasing targets by 1, we're going to set our moves equal to target minus 1. And then we're going to short circuit this loop by setting our target equal to 1. So in these test cases where we had really big numbers, what's going to happen is that if it recognizes that we have no more max doubles, it's going to increase our moves by the amount of the target remaining minus 1, because we don't want to decrease it down to 0. We want to get it down to 1. And then we're going to short circuit our loop by setting target to 1. And this will be a much quicker solution rather than just decreasing by 1 every single time. So I'm going to run this with the test case examples and just to make sure I have no errors. And yeah, 0.68 68 milliseconds is significantly faster even for these big numbers. So now I'm going to submit. And yes, 75 milliseconds, some good memory usage. This was a much better solution that we originally had written up. So that does it for this problem. If you have any questions, if you have any improvements to my code, or if you have an answer of your own, please share it in the comments below. Again, I am not a professional developer or a teacher. I'm just a novice that is trying to improve my coding, whiteboarding, and technical communication skills. So all comments and tips are welcome. Thanks again for watching.